never knew that when I saw a stream there was an emoji maybe. Okay. Da, 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 da. Hi Priya! You're here early? It's not even a minute yet. That's fast? Yeah, pretty good. Just gonna finish up with the review so I can catch up on the program and stuff. Oh. Okay, I added a new ad on a chat overlay that was supposed to pop the chat messages on screen like Nico Nico. It's not doing it. I'm quite surprised. Let's see if it works. No, it does not. Um. um, 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 How's your day, Priya? You see everything? You're just like me, always looking. Palapapam, palapalapam, palapalapam, palapalapam. I think I left off 44. No, it's 40. Factorial. I already went over factorial. Why do not repeat yourself? Scope. Place and time, which I think. Namespace. How is that namespace solution issue? Namespace. It's so hot today. What's the temperature? Dang, it's almost 30. I was gonna do something and I forgot. What's that something I was gonna do? Oh, alarm. Supposed to set an alarm. Alarm, 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 alarm. Okay, got it. Pam 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 pam. Pam padam pam padam. It's a function. I don't like recursive. Recursive function's hard. Oh god. Not just you, Lumia. I'm hungry too. I actually forgot to eat. Do I have snack? Oh, I have chips. I have potatoes. I have roasted potatoes and chips. I always have potato with me though. No, poor Lumia. Lumia's always hungry. Just like me though. I forgot how to feed Lumia. How do I feed Lumia? Thought there was a way to feed Lumia. Yum, yum. Yum, yum, yum. Ah, find it. There we go. Hee. Nice. You haven't eaten yet? Isn't it late? It's midnight. You should eat something. I only now see the new name of the channel. That means you missed the poll too. I had a poll choosing back in like what was it, December? Or January? I set a poll for two names. One was Hoshisuke Kokoa and another one was Hoshisuke Nagisa. Yeah, go to the kitchen and make me a sandwich. Feed me! Give me potatoes! Surrender all your potatoes to me! I'm hungry. I want potato gratins. Oh my god. I want potato gratins. I want hash browns. I want the loose hash brown too. Those are really good too. Like, I'm pretty sure that's not the name. I also want potato wedges. Shoestring fries sounds good too. Oh my god, I want some more Five Guys Cajun fries. I'm so hungry. This is not fair. I want mashed potatoes too. Wait, I have mashed potatoes. Screw that. Potatoes. Potatoes. Oi. Potatoes. 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 Potatoes, 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 potatoes. I want my potatoes. Potatoes, potatoes. 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 No hydrate. Just potatoes. potatoes. Give me potatoes. I want your potatoes. Potatoes, 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 potatoes. I just need her. Okay. I heard there was a second one. That was a very dissatisfying sneeze. What in the world? I don't like that. Sneeze should be satisfying. No, not the liquid mashed potatoes. No, they should be like a little bit chunky, but like mostly smooth. That's the favorite kind. Spicy drink. I got a spicy drink, a sweet drink, a protein drink, hot drink. Oh, no cold drink though. Eh, thank you. I've been blessed. Mutatable, immutatable. I have this. I have hot drink. I have vanilla milkshake flavor protein shake. The design is really cute too. It's blue. It's pastel blue. I also have the cereal flavor one. It's actually not very sweet. Surprisingly. I'm so used to seeing stuff here like being really super duper sweet. But design is so cute, so I'm keeping that one. I don't know why protein drinks has been going on a sale lately, but it is on a sale. And I need to eat more. I need a spoon for my mashed potatoes. Pen. I'm usually not a big fan of vanilla stuff unless it's Tillamook or Tillamook ice cream. Those are really good, but I have not tried the French, classic French and the vanilla bean one. I have tried all the other funky, less common flavors, but not the French one. But I bet they're really good too. Oh my god, I crave it. The ice cream is so creamy and good. Pick up ice cream. I still haven't tried gelato. I've tried sorbet. I've tried sorbet from my gelato place. Wait, no, actually, I had tried gelato once. It was avocado. Oh, it was good. The espresso was so good. Oh. The gelato was creamy too. I actually don't think it was gelato, but it had some yum 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 yum. What flavor was it? Panna cotta? I forgot what is it. It was like pan and cheesy, but not like cheddar cheesy. Or like the cheesy milk foam. I can't remember what it was called. Oh well. I'm gonna torment everyone with my studying tool. I have 70 seconds, you know what? Perfect to get my mashed potatoes and to heat up my roast potatoes too. plain old bottle continue. So I didn't see always up but up. Money knows. I do have money knows. No. I can see you cursing me, and I do not appreciate it, Priya. What do you mean I will never retrieve it? How dare you? I can't believe you would say that.
It's actually our first list. To make a list an item of itself, we use set. So this here, where the list is set as the new third item of itself. Just because it's going on in memory. The data of the list consists of a sequence of addresses, and now the third address in the sequence is the address of the list itself. Another important distinction of programming is between the concepts of quality and identity. When we say that two values are equal, we mean that they have the same type and the same content. So say, if you have two strings stored separately in memory, if both of those strings represent the same sequence of characters, then they are equal to each other. In contrast, when we say that two values are identical, we mean that they are not just equal, they are actually the very same value stored in memory. In other words, they are not separate values at all, but really just one value. So any value in memory is of course equal to itself, but it is also identical to itself. Because multiple variables can reference the same value, it can be useful to have a test for whether two operands are identical. In Pigeon, this is called the ID operator. Here we create two lists with the same values, assigning one list to Ed and the other to Tom. Because they are both lists with the same content, they are equal, but because they are two separate lists in memory, they are not identical. A key is a value which is used to point at another value. It's a value which uniquely identifies some other value. A key and the value associated with it are together known as a key-value pair. A key-value pair is an associative relationship. You have a value which is known by its association with another value, a key. Key-value pairs make up our other kind of collection type, what we'll call dictionaries, whereas a list is a collection of values organized in sequence and known by a numeric index.
If you're so profitable, why do you sell a course? Well, you know...
In a dictionary, there is no order. Instead, there are just a bunch of key-value pairs in no particular order, and no two keys can be equal with each other because the values are indexed by the keys. To create a dictionary, we use the dict operator. In the top expression here, we create an empty dictionary, and in the bottom expression, we create a dictionary with two key-value pairs. The key-value pairs are written with key first, followed by the value. So in this example, the key 77 has the value 0, and the key last has the value true. Again, be clear that there is no sense of order among the key-value pairs, so it doesn't matter which order you write them in. The operators len, get, and set can all be used on dictionaries as well as lists. Here we assigned a Ted a new dictionary with two key-value pairs, the key 5 with the value 2, and the key yo with the value -1. Len Ted first returns 2 because the dictionary has two key-value pairs. Get Ted yo 0 returns -1, the value of the key yo. Set Ted yo 8 changes the value of the key yo from -1 to 8. Len Ted still returns 2 because the number of key-value pairs has not changed. Get Ted yo returns 8, the current value of the key yo. Set Ted 21 false is a new key-value pair, a key 21 with the value false. Lastly, Len Ted then returns 3 because the dictionary now has 3 key-value pairs. So like lists, dictionaries are mutable, so we have to be cognizant of when they are modified. Here we assign an empty dictionary to a variable cow and also to a variable goose. Set cow name Fred adds a key name with the value Fred, and then get goose name returns Fred because goose and cow reference the same dictionary. So when might you want to use dictionaries? Well, imagine you have a program in which you need to create information about a bunch of people. One solution would be to have a bunch of lists, such that one list stores their names, another stores their addresses, another stores their phone numbers, and so on. These lists would be kept in sync such that the info of one person is stored at the same index in each list. For example, the address at index 5 of the address list should be the address of the person whose name is at index 5 of the name list. While workable, this solution is error-prone. A better solution is to create a single list of dictionaries where each dictionary holds the info of one person, e.g. the person's name is stored as the value of the name key, and the person's address is stored as the value of the address key. Here we have a function we might use to create such a dictionary. The function takes a name, age, and social security number, and returns a new dictionary with those values. We can then call this make person function like so, with the string Mike Smith for the name, 43 for the age, and 5555555 for the social security number. The function would then return a new dictionary with the key name with the value Mike Smith, the key age with the value 43, and the key SS with the value 5555555.
It is my first language.
So that's actually everything to know about Pigeon. I imagine you're wondering what makes real languages different. Well, first off, as we already discussed, Pigeon has no way of doing interesting input and output beyond simple text input and output on the console. If Pigeon were a real language, we'd have some means of doing things like reading and writing files, getting mouse input, and drawing graphics on the screen. Other things which Pigeon deliberately lacks are convenient.
Wait.
And the key SS with the value 5555555.
To
So that's actually everything to know about
What's
Pigeon.
wrong, Pigeon? Okay, Pigeon. I don't know.
You're wondering what makes real languages different. Well, first off, as we already discussed, Pigeon has no way of doing interesting input and output beyond simple text input and output on the console. If Pigeon were a real language, we'd have some means of doing things like reading and
You
writing.
can make libraries. You literally just explain what functions are. Just make your freaking library and then develop that, and then you can do more than basic input and output.
Files, getting mouse input, and drawing graphics on the screen. Other things which Pigeon deliberately lacks are conveniences, such as an easier way of writing loops that isn't so verbose.
Writing loops, but. Do while. Wait, okay. You didn't use do while this time. That's Java. That's in Java. Okay. Pigeon has for loop, while loop, and if else statement. I mean, isn't it just like Python? Are you shitting on Python using your fictional language?
Lastly, all of the tiny programs we wrote were all written as one file of source code. In any non-trivial program, though, you'll want to separate your source code into multiple files for organizational purposes, because past a few hundred lines, keeping all your code in one file becomes more and more impractical. So real languages give us ways to modularize code into separate source files. All of this said, aside from input-output conveniences and modularization of code, most real languages don't have all that much going on conceptually, which we haven't just seen in Pigeon.
You know what? That's one thing I really want to do is eating mashed potatoes with chips. But damn it. I only like eating one thing at a time. Also, I don't like my chips getting like mushy. But potatoes and potatoes. Those are so good. I wanna try baked potato filled with mashed potatoes. Potatoes. Potato, 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 potato. Virtual machine. Oh, I need to learn how to use a virtual machine for my homework. God damn it. Okay. I still suck at trigonometry for some reason. Like, I'm both good and bad at it. It's like, how do I get a good grade but simultaneously being so bad that I don't know what I'm doing almost all the time? How is that possible? Have I actually watched the videos here? Huh. Interesting. I don't remember. I have inertia. No, I don't. Why don't I move this to my... Where's my map? Come back here. Get your ass back here. Okay, good. Stay there. Let's go back to... Oh no! I just want to review. Stop giving me so hard. Mana. I think Priya left. That means I can steal his potatoes. Introduction to PBS.
Hello world, I'm
Digital
Carrie Ann
Studio.
Philbin and welcome to
Okay.
Crash Course Computer Science. So, computers really have allowed us to do some pretty amazing things. Think global telecommunications, international commerce, global transportation, breakthroughs in medicine, distributed education, online shopping, online dating, just the internet in general.
Okay.
Computers are allowing us to explore our own world and other worlds, and of course, some seemingly mundane things like permitting us to spy on our pets from work or communicating with our friends in a nearly indecipherable stream of emoji. But don't call computers magical. They are not. I repeat, are not magical. So before we get into what we're going to talk about in this series, it might be useful to tell you what we are not going to talk about. We aren't going to teach you how to program. Programming is a really crucial aspect of computer science, and we will get to the rules that guide the logic of hardware and software design. But we aren't going to teach you how to program an Arduino towards your plant or how to change the CSS.
Okay, I do have Adreno. That's what I'm trying to remember. Because I know I have both Raspberry and Adreno, but I misplaced all of them. So, at least I found one, and I'm pretty sure that was Adreno. I think.
A grandma's sewing blog, so visitors' cursors turn into kittens. This also isn't a computing course, or at least how computing is thought of in the US. Computing here is a goal, it's what computers do, and we'll talk about some of that for sure.
Wait, what
Visitors'
is it?
cursors turn into kittens. This also isn't a computing course, or at least how computing is thought of in the US. Computing here is a goal, it's what computers do, and we'll talk about some of that for sure, but our goal for this course is much broader. But computing means other things in other countries. It's all pretty confusing. But what we are going to look at are the history of computers, even before we had electricity. We're going to retrace the design decisions that have given us our present day components. We're going to talk about how operating systems work or don't work, how the YouTubes get to you over the internet, how our smartphones and other smart devices are getting smarter, and of course mysterious futuristic stuff like quantum computing and frustrating present day stuff like hacking. It's a lot to cover, but I suppose before we get started I should introduce myself. I'm Carrie Ann Philbin. Hello, I'm an award-winning computing teacher, author of Adventures in Raspberry Pi, and the creator of a YouTube video series for teenagers called The Geek Girl Diaries, which includes stuff like interviews with women working in technology, computer science-based tutorials, and hands-on digital link style projects. In my day job, I help people learn about technology and how to make things with computers as Director of Education for the Raspberry Pi Foundation, which is a charity based in Cambridge in the UK. Needless to say, I am passionate about this stuff, but not because computers are these amazing devices that are always making our lives easier, sometimes that's debatable, but because computers inarguably have become pivotal in our society. From our cars and thermostats to pacemakers and cell phones, computers are everywhere, and it's my hope that by the end of this course, you'll have a better understanding and appreciation for how far we've come and how far they may take us. I'll see you next week.
Imagine being able to build an app with your name on it, just by thinking about it.
No ads. Also,